But hi, everyone. My name is Amal Hussein. I'm really excited to be here today. I've had a really busy few weeks. I actually recently joined NPM as an engineering manager, so I made a pretty big transition. Maybe some would consider over to the dark side. I hope not the dark side. And actually, yesterday's talk on engineering leadership was like not only inspiring, but I think like maybe my first official training even, so thank you. That was awesome, wasn't it? Can we like, are they in the room? Can we like give them applause? I think it's kind of like solid applause. So I'm really excited to be talking to you today. So previous to joining NPM, I worked at Boku. I'm based in Boston. Many of you may have even come to our offices at a meetup before. So a lot of the, I think, ideas and inspiration behind this talk are heavily inspired by my time at Boku. I was a senior open web engineer, and my last big project was really cool. I was a tech lead for gaming, Scratch-based game console that like shipped on a single board computer that used computer vision, and I learned a lot about metaprogramming because Scratch, Boku was a big part of rewriting Scratch, which is a programming language for kids, and we kind of helped migrate it from Flash to JavaScript, HTML, and CSS, which is primitives of the web. So I've been we've done a lot of work in standards, and Boku was kind of my first real exposure into the standards world. So it's a huge privilege to have kind of been able to skim both worlds as an implementation engineer and working on standards. So other than that, yeah, I identify as a woman, person of color, child of immigrants, all that jazz. So yeah. All right. All right, so this talk is going to be about, there's going to be a lot of like philosophical hand waving in the beginning, and we're going to do some technical deep dives. But really, it's about React and the web platform Delta. So my boyfriend is an Android engineer, and I told him the title of my talk, and he was like, what? Like, I don't get it. And like, it seemed like really confusing to most people. And so I'm gonna have to like, just take a minute and explain. But frameworks, tools, libraries are often solving some problem. And UI libraries, like React especially, really kind of lead the way in terms of innovation and kind of oftentimes kind of fill gaps for the web platform. And so what we'll be talking about today is what those what gaps React was attempting to fill, if those gaps are still valid, because React's been around a long time and the platform's changed. And we'll be like, yeah, learning about what kind of like where things are and really where React, in my opinion, kind of falls short, and how we can be better informed and hopefully make better micro decisions as we're writing code in our applications. Does that sound good? Yep. All right, sweet. So this talk again, lots of hand waving in the beginning, right? So it's like one part, like there's some analysis and there's critique and there's a lot of love, because I, like you, love this tool. It changed the way I understood front-end work, There was kind of a lot of magic in the old days, for me anyway. I kind of started doing front-end code right around like the Backbone, Angular 1X, CanJS days, and like they were really complicated, and especially with Angular 1X, there was just a lot of magic. It was really easy to kind of get started and get going, but then it like got really hard once you went off the beaten path. And with React, I just felt like it was the first time I just didn't constantly mess up, And I could just, there was no magic. I knew what was going on. And I have to say, it was probably like my kind of hockey stick moment with JavaScript as well. And so in many ways, I owe a lot of my career to like React, and maybe all of us today. But with every tool that we love, we have to criticize as well, right? Because to love something is to want it to be the best. And so I want us to be okay with criticizing, and like no shaming and no like hive mentality. Like it's, it's cool to judge in the right way. So we're going to start our story all the way back in jQuery land. Where actually a lot of my former colleagues at Boku actually started out of the jQuery core team. So Boku really specialized in web platform interoperability because of the deep expertise that they got doing that, working on jQuery. And so jQuery, I guess how many people in this room wrote jQuery? Okay, that's a really good number. It's really impressive. And so I wasn't expecting that much because like I thought like React was for like all the cool young kids. Like, y'all are old. So, I was like half like I think like 70% of the room just for the recording. So all right. So anyways, now I can't sound like old and cool. Like I was like, you have to change my pitch now. What am I gonna do? Okay, so jQuery, since you already know, filled the gaps of the web platform, right? There was DOM wars, there was all of these things happening, all this crazy stuff around proprietary code in the browser. Browser manufacturers weren't following standards, and people still had to get work done. And we were sick of conversations like, who are you? I'm Netscape. All right, I'll give you code for Netscape. That was ridiculous. It wasn't a way to work. And so what jQuery did is it kind of gave us space to fill the gaps in the platform so that we could be productive as engineers. But also it gave the platform space and time to kind of, end the wars and then start a new war, because there is a new war, and we're gonna maybe briefly touch on it. But let's talk a little bit about the web. So the web is built on open standards. We know that we generally try and not break the web. And there's a humongous kind of overhead that comes with that. And so I don't think we often think about it as web developers, but we've been writing for the web since 1990. And since 1990, we've accumulated a ton of tech debt. The browser was built to be a document reader, and the web has changed, right? And so there's all these constraints around how do we keep our legacy APIs going, because the web is bigger than all of us. It's bigger than you and me. It's bigger than Webpack versus Rollup. It's bigger than Smushgate, right? There's people all over the world that rely on it to sustain themselves, and they don't have a quarter of the privilege that we do, and so we can't break the web, right? And so browser wars happened, and it kind of, I think, spurred this whirlwind of innovation within the web community. And so for me, web developers, every time I'm in a room full of web developers, I have to say this, y'all are the smartest we are. But it doesn't sound cool to call myself smart. But you are really just the smartest, most creative, most ingenious people ever, right? Because who else works in the kind of conditions that we do? In terms, really, we're kind of a little hostile, right? So are you a browser? Nope, this is a curl. Mwaha. Do you support modules? Are you IE? I don't know. We don't know. We never know, right? And so we have to always be prepared, and that's hard. And therefore, we have this swarm of people that are pushing the web and participating in the web and are whining about the web and so it's this gamut of this hay ball that just is slowly moving forward, and sometimes it seems not moving fast enough, but surely moving. And so I really want to highlight one really important case study about the web. So since we all know that y'all are super old, you know about promises before promises were in the browser, right? So promises have a really interesting history because jQuery deferred was the first kind of promise-like thing for JavaScript. I mean, the concept of promises is an older computer science design or algorithm, right? Whatever you call it. It's not something that like we invented. But jQuery was the first to kind of put it into the hands of web developers writing JavaScript. And then there was, all these other libraries that kind of formed, Bluebird, all these other things. And then slowly but surely, because of the open source model, people are using third-party code. And you're using deferred, and I'm using queue, and like every time I have to do an asynchronous handshake with you, like things are fuzzy and like I don't get this, like let's get together, we all have enough adoption, let's try to standardize. And so these library authors, all like web developers in the community created something called an A+ promise spec. And so they basically created a standard for how promises interact with each other. And this is like, it's kind of revolutionary. Now, I mean, in today's world, it's like, it's hard for me to think about a lot of these library authors like coming to consensus on something like this, but they did. And they came up with an API. They were able to do handshakes. And oddly enough, like jQuery, because of how like widespread jQuery was, ironically, it's the library that couldn't comply to that standard. But that's okay, because somebody had to take one for the team, right? so anyway, so A+ promises became a thing, and like that was working, and like we improved on that standard, right? It was a real spec that grew with the community and the needs of the community and the needs of the web. Sorry, can you guys see my screen? Oh, sorry about that. Yeah. And so eventually, as part of ECMAScript 2015, ES6, promises made their way into the browser as well, into the language, I should say, into JavaScript runtimes. And that, to me, is like one of the most interesting, like the trajectories, and such a good example of not only how one library or one design pattern change our platform, but it's an example of consensus-driven work amongst many people in our community, like pushing forward the web. And so web developers are like really critical to leading iteration on the web, and really, for me, like enter React there, right? So we fast forward to 2013, and we kind of have a newish war where the browsers are starting to be a little bit more interoperable, not 100% there yet. But React was like, hey, like we need to innovate, and we need our teams to be productive and faster and all of that. And so here, world, take React. And for me, React just made sense, right? It, like I said earlier, the layout and everything else was like perfect, and it just made sense for me. And the way it caught on like wildfire, which is why we're all here today, many years after the release of React. And so, and again, the biggest success factor for me with React was there's no magic. It was just JavaScript, right? But then, like looking back on it now, it's the web is still built on 3 primitives, for better or worse. Whether those primitives make sense for the way we need to build modern applications is another thing. We still have those constraints, right? Those 3 constraints: HTML for markup, CSS for styling, JavaScript for interactivity. And so let's talk a little bit about what React brought to the table that was super innovative. And I'm going to start with JSX, and I have a lot to say about JSX. So, so we have 2 camps with JSX. The first camp is like, yes, I get to write only JavaScript, like awesome. And then there's the like, get that markup out of my rendering logic camp, right? So I'm curious, were any of you like who like always was in camp A? Okay, who was in camp? Who started out in camp B? And who's like, I don't know, who switched? The rest of you like don't have an opinion? Yeah. Basically, did JSX make you angry? No. It didn't. Okay, if JSX made you angry, like the first time you saw it, like raise your hand. Okay, decent number. And the rest of you, I'm going to assume that you all are happy campers. JSX is actually, so it says syntax extension to ECMAScript. So it needs to be pre-processed with like transpiler. And ultimately, like, we're able to now write HTML-like markup and have that compile down to something that actually is just JavaScript, right? So a lot of us don't write code like that, which is fine, but you can. And in fact, you actually technically don't even have to compile React if you write it in the way that kind of circumvents JSX. This is a thing for some people, and so if you don't want to ever have, if you don't want to have to go through a build step, you can write React like this. And so essentially, you create an element. The first parameter of that element is always going to be a React component or like the tag of an HTML element. The second parameter is what what attributes or props you're going to be passing that component, and then the third parameter is like what child elements, and that could be more DOM, or it can be like something that's like an actual finite leaf value. And so and you can take that element that you create and just render it to the DOM, and boom, you're done. Like no compiling required. Super fancy, right? So let's talk about the good parts before we get into the not so good parts about JSX. So JSX, super declarative, right? Really easy to read. It's composable. You can actually nest your UI, and you can have your just like an easy way to visually kind of layer your applications. It's really easy to unit test. Like I really hated unit testing on the UI until React, and so it's just like was easy all of a sudden. And that includes Angular, by the way, because there was like, 3 lines of Angular test code, and then there was like 27 lines of setup. Remember, like all of the like mocks, and it was just all the dependency injection craziness with Angular. And the best part about it is also that you can inline your JavaScript with your markup, right? And so do you remember all that crazy stuff with all of the templating engines where they would invent their own new syntax for how to filter or how to loop, ng repeat or pipes or this or that? And so like in addition to knowing JavaScript and HTML, you had to like learn the way to do the thing that they did, and so it's too complicated. Like ain't nobody got time for that. And like, I certainly am glad, React came along when it did, because I was like up to here with Angular. And I just posted a little snippet of the thing that I hated, making those filters and those pipes. So some of my actually old colleagues like that I worked with are here, and like I'm sure you're having a laugh, because you know how much I hated that. So JSX, the less glamorous parts, right? So there's kind of a lot of problems because React kind of like, I'm not really sure why, but kind of really aggressively went off the beaten path in terms of not kind of complying to the DOM specification around how attributes are handled, whether that's like casing for events or casing for, or just data types, right? So like when you're passing down arrays or objects to your data attributes, there's a lot of things that are like just like really the opposite of the web platform. And some of those things are because of JavaScript, and we'll get into some examples of that. And some of those are like are not. Let's take a look at. Let's talk about the first thing, which is that like all of the event handlers, for better or worse, in native HTML are lowercase, and in React they're not. And we're gonna towards the end of this talk, we'll talk about synthetic events, which is, React kind of invented their own eventing system, just totally super venting the browser because of interoperability issues, which maybe are not, they were never actually that bad, and they're not really not present as much now. So we had casing issues with our, like a mismatch with our event handlers. and the exceptions being ARIA and data attributes, which you can lowercase. You can't really use inner HTML. You have to always dangerously set your inner HTML, so you're like doing it in a smart way with a key. It's like, yeah, we all know about cross-site scripting, like whatever. But anyways, so classes, right? Bye-bye class. Bye-bye happy designers and other folks who enjoyed maybe working with us in our code bases and maybe don't find it as accessible anymore. And so same thing for for, right? So that's another attribute that's also, kind of now HTML4. And we, yeah. And I can, actually, sorry, I had a mismatch here. So to double click into why class name and for are not standard, it's because they're actually reserved words in JavaScript, right? So remember, React is JavaScript. And so if you think about it, like, tokens, like every kind of token in JavaScript, like whether it's like a reserved word like delete or whether it's something like equal, those are things that you can't really just use for other purposes than what the compiler expects. And so you can have class and for be property names in an object, but you can't have them be variable declarators or identifiers like as in functions, right? So so you can see here in my example. I can use it in an object, right? But like I get syntax errors for everything else, and so that's why we kind of have to do that workaround. And there is technically a way for React to actually abstract away this complexity for us, but it would be something at compile time, and like there was a lot of kind of argument back and forth within the team, and like they just kind of stuck with this, but this didn't have to be the way, just to, we could have tooled ourselves out of it. And so going back to styling, so styling is another thing that like we kind of deviated on in React land, right? So we have, okay, cool, it's awesome, like to be honest, that I can dynamically set my styles in JavaScript. It's like the best part. But it's also kind of a pain when like I always get the casing wrong, and so like, and then there's another inconsistency factor with casing because like uppercase for browser prefixes except for IE, and so I mean like I get it, IE is dead. Like but still, there are lots of people in the world. Like it's dead to us, not dead to the world. That's the PC way to say it, right? So it's another delta here. And so custom elements. How many of you all know about custom elements? Okay, so maybe about like 20%. So custom elements are one of the primitive, like one of the actually four parts now of web components, right? So every like web components like shadow DOM, custom elements, was it templating? Yeah, like forgetting now. So those primitives of web components you can use, like you don't have to use everything together, but basically custom elements actually allow you to create your own actual like element, which is super useful for lots of things, especially if you want to try to use that in an encapsulated manner with shadow root or have it be something that's a bit more declarative, maybe for folks who are using screen readers or even just for yourselves as you're kind of moving like more towards semantic elements. But either way, like they're valid elements. They're like they are a thing that the browser, like it's like saying, I respect you, div, but I'm only into spans, So we can't be mean to custom elements. But so there's this awesome Rob Dotson, who's a developer advocate on the Chrome team, super big into accessibility, and so he created this great site to help framework authors try to better conform, right? And he kind of took the right approach because, to be honest with you, like anytime I want to get a group of engineers to do something, like I better make it easy for them to do it, right? So set up testing, set up infrastructure, add linting rules, have something that they can like be binary about, right? Like make it binary, and like having a test suite that you can actually use as a conformance is like a great way to drive consensus, on design and also interoperability. And so custom elements everywhere is a site, and React, out of all of the frameworks, React is like the only one that's like, well, React and Preact. And Preact, actually, the limitations are because they want to be backwards compat with React. But even Preact is like, I don't know, they're like 90% or something. They are better. And so let's take a look at, so yeah, 71% of those tests are passing. And let's take a look at like what some of those tests are. So you can see here, it's data types for data attributes. It's casing for events and all this other stuff. And to be honest with you, like these types of things are actually not just limited to custom elements. They just happen to show up in this conformance test suite, right? And so it would be a problem. It's like, so these are problems. And the thing is, like, we're kind of jQuerying ourselves a little bit because, React is kind of making certain things hidden, but to like the web platform's detriment, because ultimately, like, we actually have the resources, the bandwidth, the communication between the browsers now. They're actually all talking. They're all like, kumbaya-ish, right? Now's the time to like push things forward and really try to fix and like nip these like last interoperability issues in the butt, but it's really difficult to do so when, like a bunch of people maybe aren't even exposed to the problems under the hood. And so is there a web platform API that's similar to JSX? Like, is there a way for us to have JSX natively through like something that's available in the browser? What do y'all think? Oh, you cheated. Or I helped you cheat. Yes, there is. So tag template literals. So how many of you have used template literals in JavaScript, right? So the things that have replaced the string plus string plus string, now it's like backtick, right? So tagged template literals are like actually advanced versions of template literals. And they actually shipped with the ECMAScript 2015 spec. So they have been in the spec for a long time. And they're, I think for sure, okay, here's my order of things that aren't used enough in that spec. It starts with symbols. That's like the thing that people know the least about. And then tag template literals. And then I would say they know about generators, but they don't know what the hell to do with them. So like, that's my order. But tag template literals are up there. And to be honest, like, they're like mind-blowing because you basically are able to create a function expression around a string that can take arguments. And can you see this? Yeah, you can. It looks really dark on my screen, so I'm sorry about that. So let's take a look at how they're constructed. So what you saw here was the name of a tag, and that could be anything. That could be my name. That could be your name. It could be React. It could be JX. It could be anything. And so the way you construct these strings, this is from MDN, is literally a function. And the first argument of that function is always like an array of strings. And the subsequent arguments are the expressions. And you can do whatever you want in that function. And the example that we were looking at here was from lit.html, which is a really lightweight HTML templating UI library. And so lit is like super tiny because it's mostly like taking its HTML API and basically constructing a DOM out of it. It's pretty awesome. And so that's how they're constructed. And so basically, y'all know Preact? Yes. So Preact is basically React in 3K, and they Jason Miller, who's like an incredible human being, created a library that's actually has nothing to do with Preact. It's like an independent library called HTM, hyperscript tagged markup. And what's really ironic about that is actually HTM. I don't know, like, if you now we're going to really test how old everybody is. So HTM was like the syntax extension for a lot of HTML files back in the day, because I think Windows machines could only do 3 characters or something. So there's a lot of HTML files on the web, on retro web. So basically HTM is a library that takes tag template literals and lets you, without using a compiler or anything else, use them in React or independently, and it's pretty sweet because in addition to not needing a compiler, you can also start leveraging some other techniques around how virtual DOM is handled, and kind of separating how you do your virtual DOM reconciliation from your markup. So this is actually the way he wrote this library. It kind of works with any virtual DOM. That component is externalized, which is a really great way to write a library. And it makes me think oh, I wonder if you could just kind of create your own little Lego of React-like APIs and that are a bit more lightweight. But here's another example, which I think is maybe a little bit hard to read. I apologize. But it's this is super old school, right? So this is an example of HTM and Preact, and tell me what's missing here, if you can read it. What's maybe missing on the left that you're used to? Yeah, JavaScript. So we're able to just create this and host it in the browser without having to have a build or compile or anything step, which is pretty dope. And so you should all check that out. So HTML was created so that we can write JSX without build tools, all right? So it's old school JS in many ways. And what's really interesting about this is, by the numbers, you can compile it, right? So it's encouraged that when you're productionizing your app, you compile it, and when it compiles down, if you use Babel plugin, the Babel plugin for it, it actually goes down to nothing. I think it's completely abstracted away into your code, because it's not really a dependency, right? You're just using a web platform API, and so in addition to being totally no overhead in terms of byte size, when you productionize it, you can actually do all the things that you can do with JSX and then some, because you can do things like spread props, you have self-closing tags, Boolean attributes, right? All of the bugs around all those eventing things and attribute interoperability issues, those are kind of they're on you, right? Because you're the one who's constructing your markup now, and the browser is now responsible for interpreting it. And so, anyway, so this is cool, right? Yeah? Can we get an amen? Amen! Amen! Yes, no build tools. We spent way too much time talking about build, fixing and tweening, pruning build tools. But anyway, so next up, virtual DOM. So virtual DOM, I don't have I have stuff to say about it in the sense that there's ways for us to bring this into the browser, and we'll talk about that in just a second. But the actual mechanism itself is pretty, it's straightforward-ish, right? So basically, React kind of became famous for using a virtual DOM. It split up the calculation process and the figuring out what the DOM should do from the actual change, right? So it kind of, if you think about a river, a dam, it's kind of like a dam, right? So instead of kind of having the DOM react to everything JavaScript is doing, virtual DOM lets you schedule and batch and group, and it takes a minute to figure out, hold on, let's figure out the best path to do this, and then it executes the change. And Fiber was kind of, in addition to the virtual DOM is still there, it's kind of, they're using the word reconciler now, but Fiber did some work around further abstracting away those, that those architectures, and it enabled them to kind of shrink down their code, like the actual bundle size and everything. So virtual DOM. So I think this is the most, for me, this is actually one of the more interesting use cases for virtual DOM. So when you like render a long list, like it happens a lot with drop-down menus. Like if you have like 50 states or something like that, right? You're rendering a long list of like child nodes. If you virtualize your DOM nodes, you can kind of figure out based on what your kind of above the fold screen space is, right? You can figure out like, okay, I have like window for 10, window for 20, et cetera. You can basically virtualize that list. So you're never actually going to have like 50 or 100 or 1,000 DOM nodes rendered at a given time, right? You can actually use JavaScript or any scripting language to kind of abstract that logic away and create those nodes on the fly. And so this is like, for me, like this, I tried to find like a really good visualization, and this is like the best one that I came across. React Virtualizer is something that not a lot of people have had to run into, but if you deal with a lot of like DOM nodes and React, you start to feel the page kind of like chug, and so this kind of helps with that. Another really interesting library around this is actually worker DOM. So web workers are technically like don't actually have access to the DOM, but some folks on the AMP team created I would say like a monkey patching library that's not supposed to really be used forever, but it's supposed to help you buy some time while you're working on your performance gains. But it lets you actually use web workers to kind of do something similar to this for your DOM. And so synthetic events. This is basically what I have to say about synthetic events. Nothing, literally nothing, because it's complete and utter, like, it's completely not needed. So can anyone tell me why Preact is like as tiny as it is? Doesn't have synthetic events. And is React a library that's in production and used all around the world by lots of large companies? Yes. Okay, so thank you. This is kind of like the problem with using a tool that's owned by a company as opposed to like a tool that's owned by, I don't know, like that has like some type of standards body that's like a bit more like encompassing of other people, right? Because like I think the React team is being ridiculously stubborn about this. Like it's very simple to just say optional module. Like we, Facebook, want to keep using synthetic events because we want to bloat our apps. Like good, all well and good, but let it be optional. Like it's and for the rest of us who don't need it, like let's not be stuck with like having to use a whole like a human manufactured eventing like library, which I mean by human I should say like web developer manufactured eventing library, because browsers come with their own eventing library. And we should be trying to make that one better. And the resources and the time and the bytes that we're using to like ship all this unnecessary code, like we should just be investing those resources towards fixing the problems that we're getting away, that we're trying to get away with. And so I think the kind of the main outstanding issue from my understanding at this point is like IE 8 or something like that. Microsoft doesn't even support that, right? So maybe we shouldn't incentivize people to stay on those browsers, right? I mean, at some point, like we have to cut the cord, and these are not folks in emerging markets. I mean, these are like enterprise companies that like are running DOS. They're not underprivileged people, and so with that said, is there for synthetic events, I guess, or virtual DOM, right? Is there something that is web platform based that we can use? Right, because like the whole thing with virtual DOM is like, hey, DOM changes are a little bit more like loud and slow than I want. I want to batch and schedule and do all this stuff. to efficiently manage my changes and be more calculated. But is there something in the web platform that can do this now? Hello. Yeah, this is a trick question. It's complicated. So we can't really do virtual DOM right now, but we can do a bunch of other things. Can you tell me what they are? Pardon? Scheduling, I think that's ambitious, but you can technically. Just, it's a lot of work. What else do you think we can do? How about ship less JavaScript? If we need to, so there's this like really interesting argument in the community about like virtual DOM and the need to do virtual DOM. And for a very long time, I didn't listen to it, right? Because I'm still in love with this library, and you know, criticism hurts, all right? But lately, I've started to listen, and you know, the criticism from folks who are actually working on the web platform is like, hey, maybe it's an architecture problem. Like maybe you're shipping too much. Maybe you're trying to do too much in one view. Maybe you're not taking into account like how much screen space you have and what you should actually be doing relative to that screen space, right? So this all comes back to that progressive like enhancement that you can do for your applications. We have service workers, like they're incredible. If you haven't used them, I would encourage you to check them out. Workbox.js is a great segue into like, it's like a good way to ease into service workers because they can be like a little bit challenging. Web workers, right? So if we're sending a bunch of JavaScript that's all being processed at once, like, and if we don't need all of that JavaScript, like maybe we can, you know, spread it out and over multiple threads. We can server-side rendering. Like, in fact, that's the fastest way to render your applications, right? Rethinking our application architecture again. So there's so many things, but there is also something in the works that I didn't want to bring up with you. And you can see this issue was open in 2016. It's actually still active. There's lots of discussions. But there is something in the works being proposed around a DOM change list. So that we, you know, so having an API so that we can more surgically manage our changes the same way virtual DOM does. And this is, again, being inspired by the need from the community. So there is something in the works. And if you're interested in this stuff, I would totally encourage you to check out the issue. So with that said, like, what are the roles of people that are working on the web platform and spec authors? You know, there's always been this ivory tower between folks working on the platform and folks developing the platform. What can we do better to kind of bridge that gap? You know, what are the roles of folks who are framework and library authors, who are often kind of like 10 steps ahead of us, closer to the platform, know more about it, but at the same time, like, should there be more consensus with those groups when they start to have similar problems that they're trying to solve, right? Can we take that lesson? Can we use the example of promises to try to drive forward and be more aggressive about putting changes in the web platform, right? Like, so that we can solve new problems, because quite frankly, I think we're a little stagnant as a community, and I think we're like, I'm done with like hooks and new UI like design patterns that don't actually solve real new problems, you know? So we're stagnating, right? We have bigger problems to solve now, and I think we're in a rut. What's our role in the story of the web? You know, what's this generation's role? I know what people 10 years ago did. What are we doing, right? What's our legacy going to be? Are we building for our experience as developers? Are we developing for like our preferential tooling, or are we thinking about the health of the web platform and the experiences of our users that are like increasingly growing in diversity, you know, and have very different experiences, because we have a ton of new internet users coming online every day, and like, you know, like in their first experience of the web isn't like you and I. It's not our experience, right? Like a desktop device and like a screen this big. Like, this is a luxury that, like, I think very few people moving forward are going to be able to experience, you know? So it's a privilege. We have a privilege and a responsibility being people that are building for this platform. And to be critical of this platform is not to, you know, is to love it, like, fully. And so I encourage us all to be better stewards. And I thank you for your time.